Hello everyone, and let us continue our discussion on database management systems. Now, let us have a quick recap of what we discussed before. In the last lecture, I think we discussed about data models. So, if you remember, we discussed about 4 data models. Let us have a recap of all of them. The first one we discussed was hierarchical model. Now, in this model, remember we discussed with an analogy with family tree, like where this is your grandparent, then their children, then their children. So there was a tree kind of pattern, right? Now, the very important thing which we discussed was if a parent it is allowed to have many children, but a child is restricted to have only one parent. So we noted that this model particularly had an one to many relationship. It was for one to many relationship. Now, what was the drawback of it was if you consider any two nodes, let's say consider this node and this one. So, if you want to go from this node to the other, there is only one possible path. But in real world, this is not the case, right? What happens is in real world, if you're standing on a railway station, you can have multiple paths to go from one station to other station. So what happened in network model was all the nodes were interconnected. Like there were some connections and but basically it was having a graph kind of structure. So where many to many relationship was there. And next what we discussed was relational model. Here the data was stored in form of tables, right? So this was very popularly used. Because what happens is if you store in form of table, the data is more interpretable, right? You are able to interpret what is written. So in many places, relational model is widely used for this. But what happens in particular cases, it may so happen that any particular entry in that table may have some column which is not relevant. Like few students may not have middle name. So for that, we are wasting the space to store the middle name. So what we came up with was object-oriented model. In this model, we were storing relevant kind of information in form of objects. So this is what we discussed till now. Now in this video, we'll be discussing about a very strong model which is widely used in all companies and it is practically used, which is ER model. So what do I mean by ER? ER stands for entity relationship model. Okay, entity relationship model. Now, let us discuss this, but let's begin with what is an entity. Now, whatever you think of, like any real world object or any real world concept, we call it as entity. Now, can you think of a real world object? I think we can have student as a real world object. So, one more example can be a customer. Customer is a real world object. Then product, some product. So any real world object which you're storing information about, we call it as entity. Now, for real world concepts, we can have sales, where you're storing data about sales ID, then who bought it, what was the item bought, all those things. If you're storing, then sales would be a real world concept. So, we can say any real world objects or concepts, we call them as entity. Now, let us take a particular example of an entity which is student. Now, to define the student, what can we have? A student has roll number, right? Then a student can have name. Then the same student has some phone number. Then student lives at some place, so address. Then after address, you can have class, like which grade the student is. You can have data related to CGPA, what is the percentage marks they got. Then you can store date of birth of the student. You can store age of the student. So all these things help you to define the student. Like these are the properties of the student, right? So what we call these all properties is we call them as attributes. So basically, Uh, Attributes are properties of entities. Now, if we see of these attributes, we can notice that all of them have some unique characteristics for themselves, right? Let's just discuss one by one. Now, roll number, the first one which we discussed was roll number. Now, roll number was unique. So what happened was, to distinguish one student from other student, we used one particular field which was roll number, which was unique, and there were no duplicates. Like no two students can have same roll number, right? So we call this roll number as primary key. Okay, the this is there. Then the second one which we discussed was name. Now in the name, what can happen is you can break this name into multiple parts. Now you can break this name as first name, then middle name, then last name. So what was happening is this particular attribute can be split into further different attributes. So this kind of attribute is called as composite attribute. Then there was the other attribute which was phone number. So what happened in phone number was, now a student can have its mother phone number, then father's phone number, their own phone number. So there are multiple possibilities. They can have multiple phone numbers, right? So for this particular case, we call this attribute as multi-valued attribute. Multi-valued attribute. The next attribute which we discussed was of address. Address again was an example of composite attribute. Like we can break address into different attributes, like street name, then city, state, country. We can have these different. We can break it into different components again. So address is also composite component, composite attribute. And then what we discussed was of class. Now we cannot divide the class further into different parts, right? If it is in first class, second class, third class. So this class attribute was a simple attribute, like atomic attribute, which you cannot divide further. So it was atomic. So this is atomic attribute. Then the fifth one which we discussed was, see, we discussed about date of birth, right? So okay, so for date of birth, you have, it is a single valued attribute, because a person can have a single date of birth, right? So it is a single valued attribute. Now the next attribute which we discussed was age. Now, can you think, like, if you are accessing the database at a particular time, you have the access of the current date, then because you're storing date of birth in the database, you can easily calculate age as current date minus date of birth. You can do that, right? So the attribute which can be derived from any other attribute from that entity is called as derived attribute. Derived. So these are the different types of attributes, and yeah, let's discuss them. We have briefly talked about it just now, but a single valued attribute, it can have single values. No, this is not there. It can have single values, right? Then a multi-valued attribute can have multiple values. This had single value, this has multiple values. Then a composite attribute, we can divide it into subparts, right? Then a derived attribute was something which can be derived from other attributes. And we also discussed about atomic attribute, which is also known as single attribute, simple attribute. So it is like which we cannot divide further. So it is called as simple attribute or atomic attribute. So this is what we discussed, and let us move ahead and talk about what are relationships. Now, these entities, it is not possible that the student is alone in that database and no other entity is there. So what happens is the student is related with other entities. Like student is somewhat related to courses that, suppose this student, it enrolls in course. So there is a relationship between these two entities, like student entity is related with course entity, right? So there is a relationship between entities, which we call as association between entities. So what else can you think of? Like another example is, a book contains pages. Now there is a relationship between book and pages. So this is what we know as relationships, and let us discuss about it in detail in future. For now, just have a brief idea that it represents the association between different entities. Now we discussed about this particular component, that we discussed about primary key. So to identify each entity uniquely, we have an attribute which we call as primary key. First, remember, for student, we had a roll number as its primary key. Then for customer, we can have customer ID. We can have something which uniquely identifies all the entities. So let's, now that we're clear with components of ER model, let us now understand what is an ER model. So ER model is a high level conceptual data model that defines how data is structured in a database. Now what happens is, if you go and deliver your concept, your idea to some client, now it may so happen that client may not be from IT background, right? So what happens is, if you go and keep talking about the technical terms, the client won't understand anything and it won't be a good idea. So what generally people do is, they use ER model to provide a high level conceptual idea about whatever is happening inside, and it is very easy to make others visualize about the database, visualize about the structure of database. So it helps in visualizing database structure before implementation. Now what happens is, if a client comes to you and gives you a paragraph of requirements, it may so happen that you understand it incorrectly and you go and implement it, but at the time of delivery of the product, uh, it comes up and says that this is wrong and this is not what was expected. So to avoid this particular problem, it is better to have a ER model so that it provides clarity in database design for both developers and stakeholders. So this is what we discussed about ER model. Now, uh, for this video, that's it for now, but I would advise you to think of different examples where we can use ER model in real life, and try to describe, like try to identify the entity, and try to write its attributes. And we'll be discussing about how to make a ER model, what are its properties and all in the future videos. So thank you so much for watching. Stay tuned for part 2.